All right, 10.3, predicting intervals and some variance. We're going to look at the accuracy of our predictions. That is, not that we doubt y hat and what the regression equation can do, but there's always this sense of uncertainty. How precise is it? So that's why I would say the informal title here is finding what I would suggest would be a confidence interval for our predictions. Now we have to be careful on our wording here because confidence interval has a precise definition. And the confidence interval refers to the parameter, the population parameter. And we instead will be looking at what we would call a prediction interval, which is the range of values used to estimate things like y hat. All right, so this section is about this main topic, finding a prediction interval. All right, there's a big formula. By the way, here is the interval, and it looks precisely like our confidence interval did. That is, you take your y hat, subtract, and add the error, and our population parameter will be between those two, correct? So it is not suggested to do these by hand at all. So we're going to be using StatCrunch to find that interval. So here's our Nobel and chocolate data, and they want us to find a 95% interval for x equals 10 kg per person. So the first thing we do, obviously, is we would substitute x equals 10 into our regression equation, and that generates 21.5. But here precisely is the issue. That's an exact value. And so we want to know, like, within a 95% accuracy, what could y be? And when you do your StatCrunch under this is under linear regression, and you do summary values, and you've got to make sure you plug in 10 and your 95%, and then that generates right here at the end your predictive interval. And so rounding it off to the nearest to the nearest tenths, we get 35.3 and 7.8. So with a 95% confidence, we know that for a 10 kilogram per person consumption of chocolate, you should get somewhere between 7.8 and 35.3, the actual Nobel laureate rate. Now that is a really wide range of values, but that is because N is limited to 23 countries. If we had had more data, we could narrow that down greater, okay? So that is kind of the major deal in the homework. The second deal in the homework is this explained and unexplained variation. And this is related, it's referring to R squared, the variation, and we're going to be looking at specifically y, a particular y value, the average y, and then what we would call the predicted, the y prime. So let me illustrate those in the diagram here. Here is our y1, here is our y hat, and here is our mean. Now this is a different example, different set of numbers, different equation. There's no context here. We just have 9 as being our average, our mean value, okay, for the population. And so no matter what value you pick down here, you're always safe saying, okay, the mean value is that, so you should get that, right? Now, based upon a variable of, in our last example was chocolate, whatever it is, we can get a predicted value, and that would be somewhere along those lines. And so in this case, 13 is our predicted value. All right, and finally we would have the actual data item y1. So there's our mean, there is our y hat, and there's our y1. And so the distance from here to here, the change in y, that would be referring to as the total deviation. And then the explained, this is kind of dependent upon the variable that this regression equation depends on. That's the explained deviation. And then finally, that piece there is part of that which is unexplained. All right, and that would lead us to define our variation, r squared, in terms of these explained and total variation. So r squared is the explained variation divided by the total variation. And we want that to be as close to 1 as possible. Now, we're not going to actually go through and calculate that by subtracting and then adding those squares up. No. We're just going to take r times r. Much easier way to do this problem. So in our Nobel problem, we had an r value of 0.801. And so we square that and we get 64%. So 64% of the regression equation can be explained by chocolate. All right, the 36%, that which is left over, is the unexplained portion. All right, together these have to add up to the total 100% in this case. So here they're expressing it in terms of percentages. All right, well, that's it. That is lesson 10.3. Best of luck as you navigate StatCrunch. You're going to use that a lot.